Why hello, lovely humans. I am Jen Foxbot for another edition of Math Mondays. Da-da-da-da. Yeah! Haha! Alright. Welcome to the video series where we learn how to speak and understand the language of mathematics. Yay! Math is super powerful and we can all learn it. It just takes a little practice. Okay, so in this episode, we are continuing our exploration of key Algebra 2 topics, and we've spent a lot of time solving equations and doing that sort of thing. So now we're going to move on to matrices, and this is a new topic. Matrices are a different way of representing numbers and equations. And just like anytime we learn a new concept in a different language, we have to understand the rules that are governing that new concept. So with matrices, there are some new rules with matrices that we have to understand before we can wield them effectively. So the first thing is to ask, well, what is a matrix? What does that look like? So matrices are often written with a capital letter. So I like M because it stands for matrix, yay! But you might also see capital A, capital B, capital C, etc. C is kind of common, but I don't like writing it as much because lowercase c and uppercase c are really hard to tell on a chalkboard or a piece of paper. So I will try to stick with letters that are different between the upper and lowercase. Okay, so typically the way that we see matrices written, there's a few different ways. I like brackets, like this, where we have the different elements within brackets. You might also see parentheses or something like that. Oh, my face got a little blurry. But personally, I like brackets because it adds a nice and tight little fence around my elements. So in this case, I have a matrix that has 2 rows, and I'm going to pull out my other colors for this. So there's 2 rows. The rows go this way. And we write that like this. So we say that M has 2 rows. We use little subscripts. And it has 2 columns. So M is a 2 by 2 matrix. I can talk about the matrix as a whole. This is a good way to represent the matrix without having to write all of the elements. So I can do operations on M without having to write out what the matrix is, as long as I know what I'm doing. I can also talk about individual elements within M by calling them out specifically, and we can use the subscripts for that. So for example, if I ask, what is M1, 2, then I'm asking, what is the element in M that is in the first row and the second column. So first row, second column would be 2. Pretty straightforward, right? I could ask, what is M2, 2? And that would be 4. Yeah, all right. And so I can do operations on individual elements in M as long as I make it clear what I'm doing. Okay, so matrices, we can do some things to matrices that are similar to what we're used to. So for example, we can multiply our matrix by a scalar or a regular old number. So for example, I can multiply this by 2, and I could say 2 times M equals 2 times the whole matrix. And so to do that, I just bring the 2 in and multiply it by each element, which would be 2 times 1, 2 times 2, 2 times 3, and 2 times 4. And oftentimes you'll see matrices with just spaces in between the numbers. If you have messy handwriting like I do, sometimes it helps to write little commas to keep the numbers separate, especially when you start getting equations in your matrices. Having something to help your brain know that it's the end of a sentence, basically. The end of an equation is very similar to the end of a sentence, so sometimes you might put little commas in there to help you see the difference. The columns are pretty easy to distinguish, or sorry, the rows are pretty easy to distinguish because they're on different rows, but the columns can sometimes get pushed together. So I will let you solve this because you're more than capable of doing that, but that is just what 2m is. And we can change this number to whatever. We could even say a times m, and then we would just pull an a into the matrix. Okay. So we can also add and subtract matrices, but they must be the same size. So if our matrix is 2 by 2, I can only add or subtract matrices that are also 2 by 2. And that makes sense, right? Because if I have a matrix that looked like this, and I said add these together, the question would be, well, how? And that's a really good question to ask, because there are many different ways that you might add this onto M. Do you add this as a third column? Do you add these two columns with this column? There are too many possibilities for you to perform A plus M without any additional information. And so in order to do A plus M, these two must be the same size. But when you do have a matrix that is the same size, let's say we have 5, 6, 7, 8, then we can just add the elements in the right spots together, or the elements that are in the same spot are the right ones to add together. There we go. So M plus A equals 1 plus 5, I'm going to write a little comma, 2 plus 6, 3 plus 7, and 4 plus 8. And again, you are more than capable of doing this, these additions, so I trust that you will finish solving this. We can also ask, what is M minus A? And we do the exact same thing, but we just switch the sign on the operation. So we would ask, what is M minus A by writing it out? 1 minus 5, 2 minus 6. And just like with regular old subtraction, the order of subtraction, it follows the order in the equation. So in this case, the elements in M come first, and the elements in A come second. So then we do 3 minus 7 and 4 minus 8. I like how this one turns out, so you should definitely finish solving that for me and let me know what the final matrix is. Okay, so the tricky part with matrices comes in multiplication, because this is actually where we get a whole new rule, and whenever we're introduced to new rules, there is some form of memorization that's required. In order to know how to add, we have to understand what the rule is, right? If I say what is 1 plus 2, you have to know what this symbol means and what the word plus means. So when I say let's multiply matrices, we have to understand what that means and how that rule tells us what to do. So in this case, when we're multiplying matrices, we don't have to have matrices of the same size, but they do have to fit together, kind of like a puzzle. And the way that they fit together is that when we multiply matrices, we multiply the rows. Oh, let me see if I can find my little chalk. We multiply the rows with the other matrices columns. So let's do a simple 1 by 2 matrices. So we'll say A equals 1, 2. And I'm gonna ask, what is A times, actually let's do M times A. You'll see why I switched the order in a second, because matrix multiplication is not the same. You cannot, I want to say it's the commutative property. So A times M does not necessarily equal M times A. So again, this is where that new rule comes in. So if I say M times A, then I'm going to multiply the rows in M with the columns, if you have more than one, in A. So what that looks like, M times A, hopefully I have enough space here. So we get 1, well, I guess I should also say 2. You multiply the elements in the row with the corresponding elements in the column. In this case, we only have 2. And then you add them together. So we do that by, what it looks like is this. Oops, there's a little equal sign there. So we do the first element in the first row times the first element in the first column, which is 1 times 1 plus 2 times 2. If there was another column, then I would multiply this first row by that second column. But that's all there is for now. We'll do a harder example in a second. And then I take the second row and I multiply it by the columns. And I do the same thing that I did in the first row. So I do 3 times 1 plus 4 times 2. Okay, so I'm going to use some colors to help us suss out what in the heck is going on here. So we have 1 comes down here, and 1 comes in here. And then we have 2 multiplied by 2 here. So you can see the row is multiplied by the column. Cool, okay. And then same thing for the second row. We have the first element in the second row multiplied with the first element in the first column. And then same thing, second element in the second row multiplied with the second element in, well, the only row in this case. Cool. So that is our matrix. And then we would just solve it by doing these calculations, and what that looks like is 1 times 1 plus 2 times 2, so that's just going to be 1 plus 4 and 3 plus 8, and that is 5 and 11. So this is really interesting because we started with a 2 by 2 matrix, multiplied it with a 1 by 2 matrix, and we got a 1 by 2 matrix. So we actually lost a column. That's pretty interesting. And that is why this is not true. So we also can't multiply the rows with the columns in this case. So if we were to try and do A times M, we would be like, wait, there aren't enough elements in A for me to multiply into M. And so in that case, it doesn't really work out. So that's why the commutative property does not apply to matrices. And the biggest reason is, when we're first getting started, the biggest reason is just because this is a new type of way to represent numbers. So we just have to understand how those rules work. Okay, so hopefully that's pretty straightforward. Let's do a harder example, and I challenge you to work through this one with me. Okay, so we are going to start, I'm going to erase this and make it smaller. We're going to start with the same matrix. 1, 2, 3, 4. And we are going to multiply it by A, which is going to be, actually, I'll write it down here. and we're going to ask, what is m times a? Okay, so again, rows with the columns, but in this case, it's going to take us a little bit more time. Okay, so m times a equals 1 times 1 plus 2 times 2. And now, since we have another column, we go on and do the same thing to the second column. So 1 times 3, I'm going to add a comma, 1 times 3 plus 2 times 4. And then the same row with the last column. 1 times 5 plus 2 times 6. Look at that, our matrix is getting bigger. Ooh, okay. And now we do the second row. So second row with the first column. 3 times 1 plus 4 times 2. And second row, second column. 3 times 3 plus 4 times 4. And lastly, second row with the third column. 3 times 5 plus 4 times 6. Whew! Oh, that was a lot of work. So you can see how this takes some time. So I would recommend just going slow, and it can really help to underline as you go, and just remember rows with the columns, and you have to do each row with each column. It's not too hard, but it does take practice. So I want you to finish calculating this. I'll put the answer in the video comments so that you can check your answer when you're done. The last thing that I want to talk about are determinants of matrices. So the determinant is a special property of a matrix. I'm going to introduce it in this video, and we will dive into it in more detail in the next video, because it is something that crops up all the time, and it is super, super useful for solving systems of equations. Okay, so I'm only going to focus on the determinant of a 2 by 2 matrix. And so the determinant, or DET, of m, and this is an equation that you gotta stick in your head. And actually, I'm going to generalize this. So I'm going to say A, B, C, D. The determinant of a matrix is defined to be AD minus B times C. That's it. The equation's not too hard. You multiply these two together and you subtract the multiplication of these two together. So if we had our regular old m, 1, 2, 3, 4, the determinant of m is going to be 1 times 4 minus 2 times 3, which is just 4 minus 6, negative 2. And right now, there's not that much interesting information that this tells me, but we'll dive into that more in the next episode. Okay, so I will leave it there for now. This got a little long, so thank you for sticking with me through this. I am confident that you will be able to learn and speak in matrix language, which is a pretty cool thing to be able to do. So to help you with that, please let me know if you would like any more resources. If you have any questions, I'd be happy to answer them in the comments. And if there are specific topics about matrices, or in algebra or math in general, please let me know and we will tackle it together. All right, thank you very much for watching, and we'll see you next time. Bye!